This assessment asks us to come up with a multi-step synthesis of this carboxylic acid, starting with this alkene. What I notice is that we're forming a carboxylic acid, and there's one more carbon in our product than there is in the starting material. I know a reaction that forms a carboxylic acid and extends the carbon chain by one carbon. That would be the reaction of a Grignard reagent with a carbon dioxide molecule. If I could do that, I could form this carboxylic acid. That would mean I would need a halogen at that terminal position in order to make a Grignard to react with carbon dioxide. To put a halogen at the terminal position, I need an anti-Markovnikov hydrohalogenation reaction. Let's see if we can put those together to form this product. If we start with our alkene starting material, we could react this under anti-Markovnikov conditions. That would be HBr and peroxides. That would break the double bond, add hydrogen bromide across the double bond in the anti-Markovnikov regioselectivity, putting the bromine at the least substituted position of this alkene. I now have an alkyl halide that I could react with elemental magnesium to form a Grignard and react with carbon dioxide to form the carboxylic acid. So step 1 could be reacting with elemental magnesium. Step 2 could be reacting with carbon dioxide. And step 3 could be an H3O plus quench. And that will form my final product of a 1 carbon extended carboxylic acid starting from this alkene.